All right. Hi, everybody. Welcome to today's webinar. We're going to be talking about how you can improve your support removal efficiencies for small 3D printed PolyJet parts. So a little bit about me. My name's Francesca Baird. I'm a technical trainer here at PostProcess. So prior to PostProcess, I did get my bachelor's degree in chemical engineering, and I spent a little bit of time working in automation. As well, actually, at the end, we're going to have a case study by an application engineer who works at AdvancedTek. He's going to talk to you about those small parts specifically. His name is David. He's going to pop up on your screen once we get to his section. But what we're going to talk about is I'm briefly going to introduce you to our company and our mission. And then I'm going to talk about what traditional soluble support removal looks like. As well, I'm going to highlight some key pain points associated with these processes. Then I'm going to introduce PostProcess's new solution for PolyJet support removal and highlight the key benefits when using one of our solutions. So the ROI examples are going to cover some of the most common scenarios that we've run into, and hopefully you should be able to relate to certain aspects of each of these. Then we're going to hear from David Kalbeck, who's an application engineer at AdvancedTek, like I mentioned, and he has a lot of experience with actually using our machines when it comes to removing PolyJet support on parts, particularly our DEMI solution. So lastly, I'm going to briefly summarize everything, and then we can answer any questions that you might have. But getting started, we actually want to get to know a little bit about you. So we're going to launch a polling question. So right on your screen, you're going to have the ability to click and submit your answer. So what we're asking from you guys is, what is your primary PolyJet support removal method? Are you water jetting? Are you using some sort of tank? Are you using manual removal or tools for picking? Or are you using another method of PolyJet support removal? We'll pause here for a moment and let everybody take the time to answer. Again, you can just click right on your screen. All right, let's look at those poll results. Okay, so we're seeing 100% of our participants today are doing water jetting. So that's typically what we see across the industry as people using a water jet as well as a combination with other hand tools. But we're going to talk about the different traditional methods and then the benefits associated with switching over to one of our solutions. So getting started, a brief introduction of who we are. So PostProcess was established as the first comprehensive solution provider for additive manufacturing's post-printing needs. So we entered the space in order to allow the industry to scale to its fullest potential. We have a range of patent-pending machines that run our proprietary software and chemistry in order to provide post-print solutions across all additive manufacturing technologies. So moving forward, we are specifically going to be talking about PolyJet support removal and the unique benefits of our solution. However, at the end of this presentation, we can talk about some ways that you can access some other materials, because on the side of that slide, you can see we also offer resin removal, powder removal, surface finishing across all the different technologies. So the problems that we've seen across the entire additive industry are really the traditional approaches to solve these problems. So anybody utilizing traditional manufacturing methods such as water blasters or manually picking that support off will quickly realize that these processes just can't be scaled. So the time-consuming nature of each of these methods reduces the amount of parts that you can post-print, and this in turn creates a bottleneck for your throughput. So as you continue to grow your production, the significance of this low throughput is going to grow as well. So in addition to this, the parts that you are able to post-print will vary dramatically in quality due to the inconsistent nature of these traditional methods. So all of these pain points wrapped together make for really ineffective, costly processes that result in drawn-out ROIs for your printing production. So I'm going to dive into some of the specific pain points that you'll likely be able to relate to if you're using one or more of these traditional methods. But again, we're going to ask from you guys, what are these challenges that you're experiencing with your post-printing right now? So once again, you can just click right on your screen. Are you having challenges with the length of time it takes to finish your parts? When you are post-printing those parts, are they becoming damaged during that process? Are you having issues with the consistency of those finished parts? Or is it the throughput limitations that are hurting your post-printing? Or are you potentially experiencing another post-printing challenge? You can click right on your screen to submit your answer. Again, I'll pause here to let everybody submit. All right, let's look at the results. Okay, so we're seeing a lot of damaged parts. So that's something that, again, we typically see. Sometimes we see a wide array of answers, but we're going to address each one of those pain points that was on that slide as we progress through this presentation. But talking about, what we're traditionally seeing, so water jetting being the most common method we're seeing today, focusing on the problems that arise from that, anybody who has spent their time water jetting can really tell you that it's just not a scalable process. So you have to manually control the water jet the entire time you clean each part, which is not only tedious and uncomfortable, but it's extremely inefficient. So on top of this piece of equipment just wasn't designed for additive manufacturing and the challenges associated specific to the materials. So even after spending all this time water jetting your parts, you're still going to be left with that tacky hybrid support material layer. So then when it comes to manual labor, you get a lot of these same issues. The high breakage rates that are associated with manual labor. I mean, I know myself, if I've tried to pick apart clean, you can, in that block of PolyJet support, you might not be sure what that geometry looks like, and it's so easy to break some of the more fine featured details. And even if it's the same person cleaning off that part, you're not going to get the same results part to part, day to day. It's just not going to be a consistent part every time. And then once again, similar to with the water jet, it's time consuming for you to be spending your time just picking away at a part when there's definitely more valuable things for you and your company that you could be doing. So for a little bit of context for really what an issue support removal is across the entire additive industry. So PostProcess Technologies, in collaboration with the Society of Manufacturing Engineers, or SME if you're familiar, they conducted the first ever additive manufacturing post-printing survey in 2019. So this report provides you an in-depth look from the end user perspective of common practices and challenges in 3D post-printing today. So the data that you're looking at here shows how time-consuming the support removal process is across the entire industry, as removal processes account for 51% of post-printing. So these numbers show you that automating this process and reducing the amount of time operators spend performing support removal is going to be key for scaling printing operations. So this report, as well as other information, is going to be made available to you after this webinar. Keep looking out in your inbox for a follow-up email. But really the key to our solutions is this combination of software, hardware, and chemistry. They're all specifically designed for PolyJet materials. So in your process today, you're likely sourcing at least 2 of these components from different vendors, and this is going to create more work for you on top of the fact that these components aren't designed and tested to work together specifically for PolyJet support removal the way that our solution here at PostProcess is. So this quick slide is just to summarize all of the benefits that I'm going to dig into throughout this presentation. And the first topic we're going to discuss is how our solution is going to enable you to have higher throughput. So really the key to increasing your PolyJet throughput is by introducing batch processing with the post-process solution. So by removing up to 90% of your manual labor, you now have the opportunity to increase your productivity. So that means that all of that time that you were spending with your hands picking off the parts, now you can go and be more productive and do more value-added work. So on average, we've seen our customers are able to print and post-print about 30% more parts by introducing our software-controlled solution. So the technology behind PostProcess's solution, what we call SVC, or submerged vortex cavitation. So this technology utilizes temperature, pump flow, and ultrasonics to optimize the efficiency of the chemistry. So the level of control that the software allows over these different energy sources with real-time process monitoring is especially important for the range of materials available on PolyJet printers, as well as the complexity of the parts that we typically see users printing. So this level of control will allow you to print and post-print more difficult geometries. It's going to help lower labor costs by giving you the ability to batch these parts without risking warpage or breakage. And finally, our solution is going to increase your consistency from part to part. So each tier of our comprehensive approach really was designed with ease of use in mind so that we can minimize operator errors. So the software has a simple and intuitive interface that allows you for extensive process monitoring, or you can leave it alone and let it do all of the work without having to intervene at all. We also have options that include recipe storage to further simplify using that software. You can then just go and pull up a recipe that can be named indicative to a material or a geometry. Say if you're doing a production run of parts or a bunch of small parts like we're going to talk about later, you could just pull that up and press play. The machine provides proactive preventative maintenance warnings, and we have step-by-step videos and walkthroughs to help you navigate any maintenance that is necessary to keep your machine functioning properly. And then finally, our detergent has the ability to remove 705, 706, 707, as well as the hybrid layer in all one solution simultaneously. You never have to manually mix that detergent. It comes pre-mixed for you. You just fill it up with the machine. We are, for anybody who's starting to use the J55, we are going to start doing some testing with the 710 material. We're just waiting to have those parts shipped into us. So really one thing that I want to emphasize is the benefit of our additive manufacturing expertise. So since post-process is solely based on additive manufacturing, we can be a resource both pre-sale to make sure that our solution is right for you. And then as well, we can provide you industry-specific support for the lifetime of the solution. So we can act as a resource for you to continue to scale and expand your printing operations. And one example of how we stay so focused on additive is the fact that we do have multiple PhD chemists on staff whose sole role is to stay on the bleeding edge and continuously develop solutions for the ever-expanding list of additive materials. You know, that introduction of 710 into the support material is a great example of how, you know, we're taking that in, doing testing, and we'll have a solution up and ready to go for all of those J55 users. So now we're going to talk a little bit about a success story that we had with one of our customers who collaborated with us on a press release. So Johns Hopkins, which is a university for medicine, they were printing one part a week. You can see it in the bottom of your screen there. And it was taking them on average between 6 and 8 hours for just one part to remove the support. And even after going through that 6 to 8 hours, the part still was left with that hybrid layer, and it didn't feel real. They weren't getting the texture that they were looking for, and that was obstructing the training purposes. So the way that we resolved this was by giving them our smallest desktop unit, since they were so low throughput, they only had one part a week. We gave them our smallest unit, and we were able to reduce the amount of tech time by 85% to clean the parts, and overall even decrease the cycle time. So then on top of decreasing the cycle time and freeing up the tech time so that they could do some more value-added work, the parts also came completely clean, void of that hybrid layer. So now they mimicked that real-life simulation of the vascular model, so they were able to more effectively train on it. Now we're going to talk a little bit about ROIs, so different case studies that focus a little bit more on the money aspect of things. But before we dive into the specifics, I want to help you understand the different things that we take into consideration when calculating an ROI. So it starts with fully understanding your current print operation. We evaluate your current print cost and then what portion of that cost is due to post-printing. So a few key examples of the numbers that we look at are your labor cost, the time spent processing each part, and your percent damaged. So then we take all this information and compare it to what your post-printing cost would look like with our solution, and the result is your ROI. The first case we're going to look at, this customer was doing manual removal of supports with PolyJet parts, and so this was compared to with a water blaster, so manually blasting those supports off. So they were doing 50 plus parts a day. So again, this is going to be an example with those smaller parts. We were able to run all 50 parts per cycle. The labor rate that they were using was $55 an hour, and we were able to decrease their operator time from 8 minutes per part to just 6 seconds per part. So with the amount of parts that they were doing per day, we were able to save them over 33 operator hours per week. So per part, that turned out being a $7, just over $7 of savings per part, which resulted in a 20-week ROI. So that's just in 20 weeks, you paid off that $40,000 machine. So you can quickly see how all of that operator time really rapidly results into money saved. And not only are we saving money, but you also are now freed up to do, other things that are more important to your day. Now, another example that we have, again, they were using a traditional water blaster. So they were printing 40 parts per day. We were able to run 200 parts per cycle. And they had a really high labor rate because their engineers were the ones in there doing the manual support removal. So we decreased the operator time from 6.7 hours to just 5 minutes per cycle. So this is a little bit different than the last example you saw. We talked about the operator time per part, but now we're talking about the operator time per cycle. So this is where being able to grow that throughput really comes in. So they were only printing 40 parts per day, but now they have the ability to print 200 parts per day and post-print them at the same rate. So you can see how that would, allow them to grow their operation. You can satisfy the needs of what they're doing now, but now you can see how you could start to expand and bring in more printers and really scale that printing operation. So with what they were doing with just the 40 parts per day, we saved over 6 hours per week, which was about a $700 savings per batch. And you can see that's a little bit more of a drawn out ROI, so that's 59 weeks. But you can see how it's going to start to pay itself off even quicker as you start to print more parts. And so finally, before I pass it off to David, we're going to talk a little bit about the specifics. So here's a list of the materials that we have effectively removed in-house today. This is always subject to change as more support materials are released. So don't be discouraged if you don't see your support here. We're always happy to do more work and testing in our lab. Here are some of the different envelopes that we offer. So we have that smaller desktop unit, and then we graduate in size. And as they go up in envelope size, as you can see there, they also go up with more increasing software capabilities. So you can, depending on the size of your parts, the throughput that you have, as well as your budget, we're pretty flexible when it comes to our hardware options. So just to wrap everything up, I really want to summarize the transformative benefits that you will experience by switching to one of our solutions. So the unique software-driven approach will provide you the consistency necessary to optimize your process and plan your workflow. We remove that bottleneck that's created by allowing you to batch process your parts without risking that warpage. And then finally, by reducing that tedious manual labor, our solution is going to help you accelerate your process end to end and allow you to do more value-added work with your time. So that's everything that I had prepared today. Now I'm going to pass it off to David. Turn my webcam off.
Thanks, Francesca. Can you hear me okay? My mic working?
Yes. Sounds
Perfect.
Great.
Perfect. So just a quick bit about me. My name is David Kadlick. I'm an application engineer with AdvancedTek. And prior to that, I have a bachelor's in mechanical engineering and experience in automotive and outdoor power equipment and manufacturing and design. So one of my many roles at AdvancedTek is cleaning the PolyJet parts, in addition to many other hats that I wear. And I just want to talk briefly about this project that we're able to share publicly. We do trade shows. This one specifically was MD&M in Minneapolis, and marketing requested 100 pieces for PolyJet just as giveaways. And we're a smaller shop. There's only 2 of us that handle all the equipment. We have 2 J850s, the large production machines, and a J55. So we have a lot of horsepower for PolyJet. But our bottleneck consistently is the post-processing side of it. As you can see on the screen, we got pretty much a good chunk of the tray. It's a relatively short print, but I would probably spend the better part of my afternoon post-processing that job. And it's not uncommon for us to get jobs with that many parts requiring the better part of a day. You can absolutely crush your day with everything else and still end up with a mountain of PolyJet parts at the end of your day with the way we run things. But that wasn't the case for this one. If you can advance the slide, please. We actually have a post-process demi and a centi, so the smaller and the larger one for PolyJet support removal. And instead of me spending the majority of an afternoon using the water jet and toothpick to make sure there's no support on these parts. And for this case, it's not the end of the world if there's a little bit of support on, but in our industry, in the medical, if there's any foreign object debris, any of that little hybrid layer left, if that's going into a clean room, that's a big deal. And with post-process now, we don't have to worry about that. I spend, maybe 10, 15 minutes removing the bulk of it and rinsing it after. And otherwise, I just drop it in the system and walk away while I'm free to do a lot more productive things. The PolyJet cleaning can be therapeutic for, two or three parts. But once you start getting into the 10s and 20s and 100s, it becomes repetitive, and this post-process solution really allows us to have more of a batch process solution for PolyJet. You can see there the final project. It was during Halloween. We hung the PolyJet body parts on the tree, and we did that in about the span of 2 days. We finalized the idea, printed, post-processed, and got into the trade show very efficiently, thanks to the post-process eliminating the bottleneck for us. So really, it's a huge time saver for us, not only internally, but externally. A lot of medical customers will come to us for bandwidth issues too, and we'll do a lot of small projects. And before, I mentioned the foreign object debris, I would give them 2 to 3 days just to dry, so I could dry and spray over and over just to make sure there's none of that hybrid layer left. So the post-process has greatly improved our lead times. And given the fact that there's only myself and one other engineer handling all the post-processing and printing, we're able to take on these larger projects without having that mountain of PolyJet parts waiting for you at the end of the day. So I can't speak how much it's saved time for us and AdvancedTek. It's really been a home run solution for the PolyJet parts. And speaking just on the amount before post-process, there's certain parts we couldn't put in the tank, either because of thin walls or small features that would get warped in the tank, but we're able to control those parameters that Francesca mentioned and tone those down so we can automate the post-processing of more smaller parts with intricate geometries. So it's really been a great solution. And if you're cleaning a lot of PolyJet parts, I would highly recommend taking a look at post-processes solutions. So that's all I have for AdvancedTek's example. Hopefully you guys kind of see the value, and it really does save us a lot of time and efficiency on our end.
Awesome. Thank you so much, David.
Mm-hmm.
So I think all that we have left to do is answer some questions. So if you do want to get in contact with us and this piqued your interest, you can email at sales@advancedtek.com or give them a call. As well, we can send some links in the chat for some websites so you can go see that. But I am going to answer some questions. I have one here regarding, do you use your DEMI for removing support from other 3D printing technologies other than PolyJet? Okay, so if you saw on that first slide, it mentioned that we have other solutions for other technologies. So specifically in our DEMI, it's best used for PolyJet as well as resin removal. If anybody's familiar with any of your SLA, your carbon, your DLP, anything like that, the submersion technology works really well for that. You have a separate detergent. So if you wanted to run multiple different technologies in this machine, all you would have to do is clean out that machine and then replace the detergent. Generally, we recommend having machines, depending if you have the throughput to justify it, but having a machine for each technology. As well, we do have some other solutions if you're printing PolyJet, or not PolyJet, SDM. We have a spray technology that works really well for that. We do have some live solution experience tours that are going on tomorrow afternoon. It's actually starting at 1 tomorrow. So if you're interested on that, I'm sure you can find the link on LinkedIn, and you can see how some of our other support removal methods work. But thanks for that question. And then I have another one about how often do you need to clean out the tank. So that's really going to be reliant on your throughput. We say at minimum about every 4 months, because it's just at that point you're going to want to clean out the plumbing, make sure that there's not any solidified support or anything like that. As well, once the detergent has been exposed to air for that long, it's good to just get a new fresh batch in there. However, it could be quicker than those 4 months, and that's just going to be depending on how much material you are putting into the solution. Thank you for the question. All right, I have another question. Okay, so piggybacking off of that, how do you dispose of the waste? So that's going to be dependent a lot on what your facility looks like. So if you have wastewater handling, we do have neutralizers available so that you could neutralize that and then handle that however you see fit. But if you've ever worked with waterworks, it can be handled very similarly. So it really is going to be dependent on what your facility looks like and where you're located. So that's going to be something that our application engineers, as well as AdvancedTek application engineers, can help you out with once you're at that phase of the purchasing process. So I see it's 12:26. We have time for one last question, and then I think we'll wrap it up. Okay, so I have a question here of, can you dissolve 705 supports? Yeah, so that's a great question, since technically those aren't soluble. However, our chemistry does allow you to remove 705 supports, as well as the hybrid layer that comes with that. The one caveat to that is the fact that it's going to take a little bit longer than what your 706 takes. And as I mentioned, that 710 support that's been recently released, we'll release some posts about that once we have all of the data surrounding it. But I think that's all the time that we have for today. David, thank you so much for co-hosting this with me. I loved your testimony, and hopefully everybody who tuned in will be working together soon.
Yeah, thanks for having us.
All right, have a good day, everybody.